So let's start today's class. The class is Computer Organization, Module 1, Lecture 4. Now, last day we learned about the different types of instructions. Clear? And we also learned about the different types of cycles. That means mainly the three types of cycle, that is called the fetch, decode, and execution. What is the fetch cycle? Fetch cycle means in the fetch cycle, processor actually reads the instruction which is written in the memory. Okay, that is called the instruction fetching. Then comes the instruction decoding. Instruction decoding means processor will decode that what type of instruction is it, whether it is logical instruction or some arithmetical instruction, etc. And then the last come is the execution phase. Here the original operation of the instruction is done in the data set, where the data is stored into the main memory. This is actually the stored program concept. So this was the last day's class. Now today in our class we'll learn about the addressing modes of instruction. Clear? Now first, what is addressing modes? We know that any instruction has two parts. One is called the opcode and another is called the operand. That we already know. Now suppose this is the example of an instruction, that is add R1, R2. In this case, here add is the opcode, clear, and R1, R2, these are called the operands, clear. Now you know that what is R1 and R2. R1 and R2 is the register, name of the sum register. That means it is nothing but the address of the register. If I know the address, we can do the add on the R1 and R2. That means in this instruction, the data which is stored in the register R1 will be added up with the data which is stored in the register R2, and the final result will be stored in the register R1. Here, this is the meaning of the instruction. Here, add is the opcode and R1, R2 are the operands. Now, what is addressing modes? When we are talking about the addressing modes, we have to know what is the general definition of the addressing modes. The addressing modes, the most important activity in an instruction cycle. What is instruction cycle? Instruction cycle is actually composed of the mainly three cycles. One is called the fetch cycle, which I learned earlier in the last class. Fetch cycle, decode cycle, and the execution cycle. With these three cycles, one instruction is composed of. So that is called a total cycle of an instruction cycle, means starting point of the instruction and ending of an instruction. This is called instruction cycle. And one instruction cycle composed of the three components: fetch, decode, and execution. So the most important activity in an instruction cycle is the determination of the address of the operands. I have already told that any instruction has two parts. One is the opcode and another is the operands. Processor has to know what is the address of the operands. Okay, then only it can execute the instruction on that particular operands. So the determination of address of the operands is one of the most important activity in the processor. Okay, but how processor will know what is the instruction of an operand? Clear? So the manner in which a processor accomplishes the task is called the addressing modes. Clear? Always remember, when one vendor or manufacturer is generating some addressing modes, that means generating some set of instruction, he has to know what type of addressing mode he can use, because the addressing mode generally depends upon the organization or architecture of the machine. Okay, why I am calling this? Because suppose in the addressing of the instruction, it has given the instruction of it has the provision of the 8 registers. Then the manufacturer can write the instruction using only these 8 registers, not more than that. Okay. Similarly, if it has only 4 special type of registers, then when making the set of the instruction, the hardware engineer has to look what is the total number of the special type of register it has used, and it can only use this number of the registers, not more than that. So here the addressing mode related with the organization of the machine. Clear? When we are dividing the addressing mode, there are mainly there are different types of addressing mode. I will tell later what are the addressing modes. There are the different types of addressing modes. In this class, we will discuss the different addressing modes and what is the advantage and disadvantage of these different types of addressing mode. Clear? Now first, when we are writing the instruction, first addressing mode is called the inherent addressing mode. Clear? As the name implies, in this type of addressing mode, the opcode indicates the address of the operand. Clear? When I am talking about the addressing mode, it is better if I give the example. See the example, then it will be clear. See, this is the example. What is given in the example? Inherent addressing mode means I've told that in this type addressing mode, the opcode indicates the address of the operand. Clear? See here, the example is STC. This is the assembly level code. The meaning of this code is here. The meaning of this code is set carry flag in the status register. What is the meaning of that? Meaning of that is whenever we will do any arithmetic operation, suppose summation. Clear? One carry may generate it. Clear? There is a special type of register. Status register is a special purpose register. This register for some microprocessor operation will be set if carry is generated. Set means it is 1, otherwise it will be 0. Clear? So to do this, one can use this type of assembly level command, that is the STC, set carry flag in the status register. Clear? See here STC, this is the opcode. But see here, I have already told any instruction has two parts. One is the opcode, another is the operand. See, no operand is mentioned here, only STC, this command. But here this is inherent addressing mode. That means as the meaning of this addressing mode is set carry flag in the status register, that means it is already telling the processor check the status register which is in the CPU. Clear? That means here there is no requirement of telling the address of the status register. STC means processor will check the status register when it gets this type of instruction. So here address is mentioned within the instruction. So this is called inherent addressing mode. Clear? There is no separate addressing for that. There is no requirement of separate address for that instruction. That means only if you mention the opcode, processor will understand that processor has to check the status register, which is a special purpose register. Clear? So this is called this type of instruction. Whatever when we use this type of instruction, the addressing mode is called the inherent addressing mode. That means the address is mentioned in the instruction itself. Clear? Now then comes the next what is the advantage? The processor does not have to compute the address of the operand. Clear? Now the immediate addressing mode. What happens in the immediate addressing mode? See the example. In the immediate addressing mode, the data on which the instruction will operate mentioned in the instruction itself. Clear? Again, I am repeating, the data on which instruction will be executed is mentioned in the instruction itself. This is called immediate addressing mode. See the example. First, add #25 R1. What is the meaning of hash? The meaning of hash is here we have to add the data which is stored into the register R1 with 25. Here 25 is the data itself. This is not any address or not any register. This is the data itself. Clear? Now here when we give hash, that means this is the data. Clear? That means here one address is mentioned because R1 is mentioned here, and another data is mentioned. Clear? So this is called the immediate addressing mode. Again, I am repeating that, where the data itself is mentioned into the instruction. Clear? What is the advantage of this type of instruction? Advantage of this type of instruction is there is no memory reference. Why this is advantage? When I am talking about there is no memory reference, why? What is the advantage? Remember that when I give any memory reference in the instruction, the thing is that processor has to first fetch the instruction, then it has to fetch the data from the memory. Always remember the speed of the memory is much lower than that of the central processing unit or CPU. That means when you are using a very high speed CPU and your memory is slow, there is a mismatch in the speed of these two components. Obviously, the performance of the system will be down. Clear? That means if in a set of instruction you are giving more and more memory reference, obviously the time to execute the set of instructions or programs will be more. So what is the advantage? If no memory is mentioned there, this is the advantage. Here 25 is mentioned there, no memory is mentioned, it will directly get the data from the instruction itself. It don't have to go to any another address to fetch the data. Clear? So this is the advantage. What is the disadvantage? Size of the number is equal to the size of the address field. Your address field, you know, that depends upon the number of the bits used in the address field. I will tell in the memory. Okay. So if your bit number of the bits is limited, that means number of the address field is limited because you are dividing the total address field for the total instruction. You cannot write more than the number which is given in the bits. Suppose for writing the one address field, suppose 3 bits is given. 3 bits are given. That means what is the maximum number of address it can generate? 2 to the power 3. That means 8 address it can generate. So number, what number you can write here? Maximum number you can write 8, because that address field only gives this type of address. That is the limitation of the address field. So that is also the limitation of the immediate addressing mode. Clear? So there are 2 memory access. I have already told. One is called the opcode and another is called the data. Clear? Now here opcode means the add, that is the, and data is the 25. Clear? Then comes the another important addressing mode, that is called the absolute addressing mode. Now, what is absolute addressing mode? In the absolute addressing mode, the particular address is given in the instruction and processor will find the data from that address. Clear? That means, suppose here it is given move @ hash 5000 R2. What is the meaning of that? Meaning of that day, here 5000 is the address of the data. Remember, if I give only hash, it will be data itself. But when I am giving @ #5000, that means this is the address of the data. That means 5000 is the address where the data is stored. So processor first fetch the instruction, then it will go to 5000 address. Address is in the hex code, and from that 5000, see here bracket is given. That means the data which is stored in the address 5000 will be transferred or moved from particular address location to the register R2. Okay, clear? The absolute addressing mode. Again, I am repeating, in the absolute addressing mode, the particular address is given and the data will be moved from that particular address to the register. Here move @5000 #5000 means the data which is stored into the address 5000 will be moved to the register R2. That is called the absolute addressing mode. Why it is called absolute? Because here the address is specified in the instruction. Clear? Here address is specified in the instruction, not the data. So that is called the absolute addressing mode, and the mode was very common in the earlier machines. Mostly the earlier machines, they use the absolute addressing mode. Now one thing you should remember, that in all our modern machines, they use not a particular addressing mode, they are used actually the mixture of the different addressing modes. Clear? Now the register addressing modes. What is register addressing mode? If the operand are registers, previously we have seen, again if I go to the previous slide, here there are two operands, one is R2, another is hash 5000. So one is register and another is the address of the memory. Remember, one is register and another is the address of the main memory. This is called the absolute addressing mode. But in the registered addressing mode, what happens? In the registered addressing modes, all the operands are the register. Example, add A, B, and C. The meaning of this, the data which is stored into the register A will be added up with the data in the register B, and the final value will be stored into the register C. So here all A, B, C, all are the registers. So this type of addressing mode is called the register addressing modes. Clear? In the register addressing mode, the effective address A of an operand is the CPU register. Now the question is, what is the meaning of effective address? Effective address means when we are talking about the different addressing mode, suppose you have written any instruction, processor has to find out what is the effective address of an operand. In the previous case, I have shown here move @ #5000 R1. That means here in this case the address was the 5000. Clear? And another address was the register R1. But in this case, so what are the effective address of the operands? One is the memory address and another is the register R1. In this case, what are the effective address? Effective address, all are the registers. In this case means the register addressing mode. All are the registers. Clear? Here A, B, C, all are the registers. So effective address in the register addressing mode, all are registers. Now, what is the advantage? Advantage of using the register addressing mode is that, remember, then in the memory system, speed of the registers are the highest. Clear? That means if processor can store all the data in the register instead of the memory, obviously the speed of the programming will be increased, because I have already told memory, that means the main memory is a slow device compared to the CPU, and register, the speed of the register is almost equal to the speed of the CPU. So if processor can store the data into the register, obviously time will be less. Okay, so this is the advantage of using the register addressing modes, where all the address of the operands are registers. Clear? There is also disadvantage. What is the disadvantage? The disadvantage in the register addressing mode is the number of the registers are limited. Okay, suppose you are using a machine which has 16 general purpose registers. That means what is the number of operands you can use in a program? That is the maximum operands you can use is the 16, because as you are using the register addressing modes, only 16 register you can use. Clear? So this is one type of disadvantage, because your space is very low. Whether suppose you are using any 5 bits memory system, what is the maximum number of address you can generate? 2 to the power 5, that means 32. So see here, 5 bits you are generating 32 addresses, but here if you have only 8 registered, you can use only 8 positions there. But if you use a memory, you can generate, if it is a 5 bit, you can generate 32 different types of address. So this is a disadvantage of using only the register addressing mode. You have to use, in today's modern machines, maximum machines use not only the register. This is a combination of a register, one operand, and another is the memory. When it is stored into the register, then only ALU can do the operation, but for storing it has to store into the main memory also for program. Okay, so these are the disadvantage for using the register addressing mode. Now register indirect mode. In the register indirect mode, this is another type of register addressing mode, but here the register holds the address of the operand. Register are not the operand. Here register holds the address of the operand. What is the meaning of that? Suppose the example, move R1 within bracket R2. The meaning of that, here R1 is the register. R1 contains the address of the memory, and that R2 also contains the address of the memory, and the data from that particular address in the memory will be transferred to the memory address mentioned by the R2. Now see here the example. Suppose R1 is 1000. Remember, when I am writing here R1 is equal to 1000, this 1000 is not the data of the R1. This is some particular address. Clear? So which address is stored in the R1? 1000 address. This is stored into the R1. Clear? R2 2000. Same thing. 2000 is not any data. 2000 is the address of the memory. Now move. That means the content of the 2000. The meaning of this instruction is content of the address 1000 will be moved to the content of the content of the register is 1000. That means the data which is stored into the memory address 1000 will be transferred to the memory address which is written in the R2. That means 2000. Okay, suppose 1000, this memory address contains the data 27. Clear? So it contains at the address is 1000 is 27, and 2000 address 2000 contains the data 39. After doing this instruction, move R1 R2, this 27 will move to the address 2000. Now that means the updated content of the address 2000 is now 27, not 39. Clear? This is called register indirect mode, where the operand are the register, but within the register they are not the data, they are actually the address of the memory. Clear? So this is called the register indirect mode. Now there are the two variants of register indirect mode. Clear? They are called the auto increment mode and auto decrement mode. Now what is auto increment mode? In the see the example here, move R2 plus comma R3. As I have given here the plus sign, that means it is auto increment mode. Clear? What is the meaning of the instruction? Meaning of the instruction is that the data which is stored into the register, which is stored into the memory location mentioned by the R2, this is just like the previous one, register indirect mode, which is stored into the address location mentioned by the register will be transferred to the register R3. That means the memory location, the data which is stored into the memory location mentioned into the R2 will be moved to the register R3. Then R2 is equal to R2 plus K. That means after that, the address of the location will be increased. What is the meaning of that? Suppose, as in the previous case, at the 1000 data is stored. After moving the data at the 1000, suppose the data is stored is 27. Here 27 will be moved from that particular memory location to R3. After that, what is the address of the R2? What is the data stored into the R2? R2 was 1000. R2 plus K, suppose the value of K is 1, that means 1001. This is the next address of the R2. Clear? So this is called the auto increment mode. That means after doing the operation, it will automatically increase the address. Clear? Again, I am repeating, after doing the instruction, after execution of the instruction, the address which is mentioned into the register will be automatically incremented. That is called the auto increment mode of the register indirect. Clear? Similarly, the same thing that is called the auto decrement mode. What happens in the auto decrement? After doing the execution operation, the address which is stored into the particular register will be decremented. Okay, so that is called the auto decrement mode. Here, see here, move R2 and to R3. That means the data which is stored into the address mentioned by R2 will be moved to the register R3, and after that, the content of the register R2, that means the particular address, will be decremented by K. That means the new value of R2 is R2 minus K. Clear? There are different values of K. If the addressing is used 8 bits, K will be 1. If 16 bits, K will be 2. And for 4 bits, 32 bits, there will be 4. Clear? So these are the variants of register indirect mode. Now address modification. This is one of the important thing in the addressing modes. Now in this approach, the effective address, I have already told you what is the effective address. Effective address means the address of the operand which processor can find out or which processor is required to execute an instruction. So in this approach, the effective address is the sum of two parameters. Okay. They are called the reference address RA, clear, and the modifier M. M is also called the offset. Okay, that means this type of addressing modes, address is modified. Whatever address is mentioned into the instruction, processor have to find out the effective address from the instruction. Okay, instruction from the operands. Okay, and how it will find out the effective address? Effective address is the summation of the reference address RA and the modifier M. Clear? Now you can ask me what is reference address and what is modifier. I am giving you one example. Suppose if I ask you where is RCC, you will tell that it is in the Shialda, and from the it is first you go to the Shialda, and from the Shialda it is suppose 10 kilometer distance. So when I am talking about the Shialda station, that is the reference address. We are referring the particular address. Clear? And when I am talking about that RCC is the distance of the RCC from the Shialda is suppose 10 kilometer. So here the 10 kilometer is the offset. If I add these two, that means the address, the distance of your location to the Shialda station, this is the reference distance, and the offset will get the what is the original address of the your college. So this is called the address modification. Clear? It has the three types of addressing modes. One is called the index addressing mode, another is called the base register addressing mode, and another is called the relative addressing mode. Clear? Now, what is index mode? In the index mode, the reference address RA is included in the instruction, and the particular register contains the value of the offset or M or modifier. Okay, the register which contains the value of the modifier, okay, or offset is called the index register. It will be clear from the particular example. Suppose LDA011X. The meaning of this is load the register A of the data which is stored in this operand. There are the two operands A and this N. Okay, what is the meaning of that? Here reference address, as it is the index mode, reference address is mentioned into the instruction. Okay, included into the instruction. See here 0011010, this is the address of the particular data. Okay, reference address, not the original address or effective address. This is the reference address. Okay, and here X is the register which contains the modifier. So suppose X contains 2. Okay, so reference address is 0100 and modifier is 2. So what will be the effective address? We know effective address is the reference address plus modifier. That means 0100 plus 2. So 0102. So this is the actual address of the memory where the particular data is stored, and using that load instruction, the data will be transferred from that particular address, that means 0102, to the register A. So this is called the index addressing mode, where the instruction is where the array is mentioned into the instruction. Clear? Now then comes, suppose in the array, you know from the C language that when I mention the array Q10, clear? What is the meaning of Q10? That means the element which is stored into the 10th value of the particular array. So what is Q here? As this is the name of the array, this is called the reference address, and plus 10, this is the reference address, plus 10, the original value is stored. So this is the Q plus 10 is the effective address. Okay, where Q is the reference address, plus 10 is the modifier, and we will get Q plus 10, we will get the original effective address. Clear? So this is the index mode. Now comes the base register addressing mode. What happens in the index mode? In the index mode, in the register, the offset value is mentioned, and this is just the reverse. Here, the reference address is mentioned into the register, and offset is given into the instruction. In the previous case, offset is given in a register and address is mentioned. Here offset is mentioned or modifier is mentioned, and the reference address is given in a particular register. That means the name of the register will be given in the instruction. So see, suppose here opcode any instruction add, suppose base register addressing mode R1 3. That means in the R1 the particular address is stored. So it will, processor will go to the particular R1 here. This is a register set. From this set, it will get the data, and it will add up with the offset A plus particular address. Okay, and it will go to the particular memory location, and from that it will get the operand. Okay, this is called the base register addressing mode. Clear? This is another type of addressing mode. Clear? The last one is the relative addressing mode. What happens in the relative addressing mode? Relative addressing mode is same as the base register addressing mode, where the particular register contains the address. If in case of the base register is the PC, that means the program counter. I have already told what is PC. PC is the special type of register which contains the next instruction to be fetched. That means in the case of the if the base register is PC, that is called the relative addressing mode. Clear? So these are the different types of addressing mode. One thing, this base register addressing mode using the virtual memory. What is virtual memory? That I will tell in the memory section. Clear? So this register mode, when we are implementing the virtual memory in the system, this register mode is used. Clear? So this is the relative addressing mode, and this is for today's class.